Good morning. This week we talked about the steps of meiosis, which are the stages, the reductive stages that your egg and sperm cells go through in order to reduce the amount of chromosomes by half. This only happens in your egg and sperm cells. So in a boy and a sperm cell and a female and egg cell. And again, the reason is because when fertilization occurs, when the egg and the sperm join together, we want that new cell that's eventually going to be a human being to have a complete set of chromosomes. We do not want it to have double the amount or not enough chromosomes. In order to be, a human, a normal, technically normal human, you have to have, 23 chromosomes, 2 pairs at each, so 46 total. So in order to make sure that all of our new offspring have the right amount of chromosomes, our sex cells go through meiosis in order to basically cut the number or the amount of chromosomes in half. They're the only cells in the body that do that. So that kind of leads us to our topic today, which are karyotypes. Karyotypes are pictures of chromosomes. It's an organized way that we can take a picture of chromosomes, organize them, look at them, and then be able to determine a couple different things about the individual. We can determine sex, we can determine whether or not there's a numbers problem, as if non-disjunction took place or not. We can tell whether or not a chromosome is missing part of it. So it just gives us some basic information. If you've ever had an amniocentesis or your spouse has had an amniocentesis, what they're doing, one of the things that they do with that testing result is they make a karyotype, and this is almost always done if you are a woman over the age of 40 who becomes pregnant, because there becomes a much greater risk of having a numbers issue as women age. So to kind of make a long story short here, what we would be doing is that, let's use an amniocentesis for example, we would take some body fluids out of the unborn child, and we would basically take that fluid, we would spin it incredibly fast, centrifuge it, so that basically all of the chromosomes would start to separate themselves out, and you would get something that would look like this, okay? We would image it, so x-ray, sometimes we'll add a dye. On the next slide, you'll see what happens when we add a dye to make it more colorful or easier to see. But then we take these, then they take each of these chromosomes here, and they're going to arrange them, match them with their pair by height, okay? So if you look here, here is chromosome number 1. This is the biggest one. Chromosome number 2 is the next biggest. Chromosome number 3 is the next biggest, and so on and so forth through chromosome 22. If you look, you have 2 chromosomes in each location, okay? You got one from mom and you got one from dad. One from the egg, one from the sperm. Here, chromosome 2, you got one chromosome 2 from dad, you got one chromosome 2 from mom. One from dad, one from mom, number 3. So there are 23 pairs of chromosomes, but there are 46 total chromosomes because you got a copy of each chromosome from each of your parents. Now, if you look, chromosomes number 1 through 22, okay, so all of these are called your autosomal chromosomes. And they're called autosomal chromosomes because they are going to control everything, all of your traits that are not related to sex, okay? So you have 44 chromosomes that control things that are not related to sex chromosomes. Chromosome pair number 23, however, is a little bit different. Chromosome pair number 23, right here, is going to determine sex. So we call this one your sex chromosomes, okay? If you have 2 of the same, okay, an X and an X, like this one is, you would be a female. If you had an X and a Y, then you would be a male. So the first thing that you would do when you look at a karyotype is you're going to determine the gender or the sex of the individual. 2 of the same on chromosome 23 would indicate an X and a Y, or an X and X, I'm sorry, which is a female. And if you had one over here, which would typically, a Y chromosome is significantly smaller, that would be a male, an X and a Y. So that's the first thing that you can tell when you look at a karyotype. The next thing you can do is you can just look at sheer numbers, okay? Are there 2 number 1s? Yep, check. Are there 2 number 2s? Yep. 2 number 3s, 2 number 4s, 2 number 5s, 2 number 6s, 7, 8, 9, 10, 11. Everything's looking pretty normal so far. 2 13s, 14, 15, 16, 17, 18, 19, 20. Uh-oh, got a problem here. There are actually 3 chromosomes here instead of 2. And this one looks good, and we have 2 sex chromosomes. So we have a problem right off the bat, because instead of having 46 chromosomes, this person has 47. There's an extra chromosome on number 21. This is going to be indicative of a problem. This is going to happen because of non-disjunction, which means that either during meiosis 1 or meiosis 2, at some point the cells did not separate. The chromosomes did not separate the way that they should have. So just to go back real quick to review non-disjunction. So here's the normal division. So you have meiosis 1 that occurs where the chromosomes are split, and then you have meiosis 2 where the chromosomes are split again, and then you end up with your sex cells or your gametes, which have 1 copy of each chromosome. But in non-disjunction, so in this example, here's non-disjunction 1, because non-disjunction can occur in meiosis 1 or meiosis 2, in the first stage of meiosis or the second stage of meiosis. In this example, it happened in the first stage, so the chromosomes did not split the way they should have. This one should have gone over here, right? It should have gone over this way, and it didn't. They all ended up going this way. And so now we end up with gametes that have 2 gamete cells that have too few chromosomes, and we have 2 gamete cells that have 2, 3. And so if one of these, let's say these are 4 sperm cells that were formed, if one of these sperm actually fertilizes an egg, now we have the situation that we just saw where they're going to have an extra chromosome. If one of these 2 fertilizes an egg, we're going to have a situation where instead of having 46 chromosomes, we would only have 45 chromosomes. And this can also happen in meiosis 2. So here's meiosis 1, everything split the way they should have, but then when we went into meiosis 2 where it splits again, this should have gone one side, one chromatid should have gone in each one, but instead it all went into this side. And so once again, we have a situation where this one is too many, this one is too few. You have 2 that are actually normal. So these non-disjunction is a reason where we end up with a karyotype that has too many or too few chromosomes. So if we go back, we can see here that that is what caused this 3rd chromosome. Having extra chromosome number 21 is a condition called Down syndrome, probably something that you've heard about before. So let's just do one more practice here and look at this particular karyotype. So the first thing that you want to do is determine the sex of this particular child. So go down to this one. It's got an X and a Y. So as long as that Y chromosome is there, it would be considered to be a male, although we may talk about some things that, some exceptions to this rule. But for the time being, we're going to say that this is a male because they have a Y chromosome. Okay, numbers, well, you can see right here, right off the bat, that you have 3 sex chromosomes and you should only have 2. You should only have either 2 X's or an X and a Y. So we have 47 chromosomes. So we know right off the bat that that's going to be an issue. So we kind of circle that. So sex is a male, chromosomes, we know we have 47. The location is on the 23rd chromosome. Okay, and so this would actually be called a trisomy. Tri meaning that there are 3 chromosomes. And then you would look up what this disorder is. So you could go on the internet and look up XXY disorder. So that's how we use karyotypes in order to analyze whether or not an unborn child is genetically, or actually a born child too. You can do a karyotype anytime during your lifetime. But whether or not there are any initial genetic issues just resulting from too many or too few chromosomes. You're going to do some practice karyotypes, looking at them and then analyzing, sex, how many chromosomes there are, and then looking up what diseases that or disorders they actually represent. So, have a great day.